Fundamentals Test 9 is where we're headed today, from chapters 20 to 22 of Jim Haldeman's textbook. And we're going to talk that. You saw that little thing about that whenever I was up there. And Jim Haldeman came walking by, and he goes, "Hey, man." I said, "Hey." He said, "Good to see you. I read all your stuff." I said, "Yeah." And he walked off, and these two automotive instructors I was standing next to says, "That was Jim Haldeman. He writes all of our textbooks." I said, "Yeah, he writes mine too." But, okay. Number 1, like charges do what?
Repel.
Typically.
Tell them what you said.
They repel, they push against each other. You got two north poles on a magnet trying to push them against each other, they're going to go this way and all that. Which unit of electricity actually measures the amount of current flow?
Yeah.
This is so easy. As temperature increases, what happens?
Does the resistance increase?
The resistance of a conductor increases. That's just the standard thing. That's what you expect, right?
Yeah.
So what's the unit of electrical pressure?
Coulomb.
Ohm?
Electrical pressure would be volt. Volts is pressure. Okay, let me ask you this. How are you going to punch across the spark plug gap in a compressed air combustion chamber? You're going to have what? You need a lot of amperage, you need a lot of voltage, because, so what you do is you take the 12 volts that's coming out of the battery and you're going to step it up to like 110,000. And that's what it that's how it punches across that air gap. Now, have you guys ever heard thunder?
Yeah.
You ever heard of spark pop?
Mm-hmm.
Same thing. What happens is that spark punches a hole in the air, which is the insulator, makes a hole in it, and then when that spark goes away, you hear the shock wave come back together. You ever heard of sonic boom?
Yes.
Oh, yeah.
What happens is that jet's pushing the air out of the way. It used to scare the dog wax out of me in the early 1960s. I'd be out there, a kid playing in the yard, and I would hear a sonic boom. It would rattle every window in the house and just scare the daylight. And I would see a jet nowhere, just boom. I mean, it just come from, I don't know where it was coming from, and all that. You remember when Chuck Yeager was flying that, broke the sound barrier the first time? They heard that sonic boom. They thought his jet blew up. Remember that? They were just, and they showed all of those pictures on the wall in that place where all of those pilots that had died and test pilots, and whenever that sonic boom went boom like that, it shook all the pictures on that wall, and everybody was like, oh, because they never heard that before. And then he came out of the clouds, and they were like, wow, look at here, it's pretty cool. If you ever saw that movie, The Right Stuff, you saw that, and it was really, really good. That particular scene, I could do without the rest of the movie because it was 3 hours long. Please, if you want to pull up on YouTube, Chuck Yeager breaks a sound barrier on The Right Stuff. That's a cool video clip. You ought to watch it. It's really good. Okay, let me see. What's the unit of electrical pressure? Is volt. The outer electron shell is known as what? We have 2 or 3 different dissenting voices. Yeah, that's the valence ring. There you go.
That's the one the electrons are.
Yeah, you know about the valence ring, didn't you, Quincy? Remember when we was in class and we did the original, the outer ring of electrons, if it's got 1 electron in the outer valence ring, it's something like gold or copper. If it's got 8, it's an insulator. If it's got 4, it's a semiconductor. So the fewer electrons in the valence ring, the more room is there for them jumping. They can jump from one atom to the other that way. See what I'm saying?
What, 8 shells?
Yeah, so you got 8 places for it to go. Now,
Each level
where does the
of
current,
table.
from what I'm told, and I've never been able to actually verify this, what I've been told by everybody that teaches electricity or whatever, the current does not travel through the middle of the wire. It only travels on the outside. See, so think about that. Okay. Semiconductors have how many electrons in their outer orbit?
4.
What type of material is indicated in this atomic structure?
That looks like an insulator.
Yeah. Is that right, Alex? You got that right? That's right. You're making it, ain't you? If an insulated wire rubbed through a part of the insulation and the wire conductor touched the steel body of a vehicle, the type of failure would be called a what?
Short ground.
We may have short the ground.
Right on.
Now, how many times has somebody been talking, anytime there's any kind of an electrical problem in anything that appears to be related to, current flowing or whatever, they'll say, it has a short in it. You ever heard them say that?
Yep.
It's got a short. Quincy, you ever heard that? You ever somebody, it's got a short in it. Like if a woman's got a hairdryer that ain't working right, she'll jiggle around the cord, she'll say, it's got a short in it. You ever heard that?
I did it about hair straight.
Okay, what's the difference? I mean, what does it actually have? If I can move wires and, what does a short usually cause?
It's got a loose connection.
It's an open. is what it is. An open is whenever it's got a broken wire. But a short can cause a couple of different things. It's either going to cause something to turn on that's not supposed to turn on, or it's going to cause a fuse to blow, or it's going to melt some wires. You know, like if you've got a ground circuit that's supposed to, like if let's say you guys know how your horn works?
Yeah, it goes beep.
Huh? Your horn has actually got a ground. The horn's typically got a ground that operates the horn relay, and then the horn relay puts power out of the horn. Okay, so what if the horn's blowing all the time? Is that a short or is that an open?
That's a short power.
Well, maybe, but where would you look for the problem? I mean, hey, my horn never stops blowing. What's the first thing you're going to do? This is simple
The
stuff.
horn
Here.
relay.
Well, that's not a bad idea, but I want to know, is the horn relay stuck closed or is it being told to stay closed?
I remember, like, my friend had hit the, like, the you know, when you blow the horn, yeah, it hit it, and then the horn just, it started beeping, and it would never cut off.
Yeah, well, that's because it's got these little copper shim-looking plates, but with foam in between them, and then on some of these horn pads, and when those two copper plates touch, see, it makes the horn blow. So these little thin copper stuff, if you get mad and hit it, now you've bent it so that they're touching all the time.
I had to hit it to make it cut off.
Yeah, well, you can do that kind of stuff too, but what I always do, what I'm going to do is I'm going to go at the base of the steering column, and I'm going to find the wires, and they're usually not that hard to come by, that drive the horn, and then I'm going to unplug those and see if the horn quits blowing. If the horn stops blowing when I do that, what do I know? We're talking troubleshooting, y'all. I know that the problem's up there in the steering wheel somewhere. Now you can take your test light and hook it to ground. If you touch the horn wire, the one that operates the relay, remember how I energize that relay with a horn wire? You can energize that relay with a horn wire. I used to do that. I was working on one day, and I said, I want to see if this horn will blow like this, a honk like that. And I heard this guy in front of the car. It scared him. He didn't expect it because he didn't see anybody in the car, you know. But anyway, and some people in the service lot would get out here and they'd see somebody walking along with a fob looking for the car they're supposed to work on, and he would have his hand up there in the car, you know, and he'd go, and when he'd see him fooling with the fob, he'd go honk, honk, and make him come over to where he was, you know, thinking he was going the wrong car. All right. If two insulated wires melt together where the copper conductors touched each other, the type of failure would be caused to what?
Short the voltage.
That's basically, yeah, anytime you get two wires melted together, short of voltage. Remember I told you about that 95, huh?
So what if it's melted to the ground?
It would be a short to ground, but, you know, that's just, yeah, you know, the answer is B, but that's really not a very well-written question. I'm going to talk to him about that. But now then, and he's got a good point, it can be melted together, but
Black nose.
there was this guy that had this 95 Thunderbird, and he had put Scotch lock on there and hooked him up some trailer wires. Brand new car, and it was in 95. And so the little bitty 22 gauge brown wire that he had in there was, hello, did somebody knock, or was that you tapping with your pen? Oh, I thought somebody was knocking on the door. But anyway, that thing started melting the insulation off of that wire back toward the power source. It started at the at the Scotch lock, and it was melting it back toward the power source. And when it got up under the dash, it went across under the dash, that same brown wire went to a lot of places, and it wired just about everything on that car together.
Oh my
And
goodness.
this was a $3,000 repair, because every wire harness on that car had to be replaced. All the interior panels had to be pulled off. The wire harnesses went out into the doors. I had to replace all them harnesses and everything, and that was a booger bear of a job. And it was his fault, because he didn't get the trailer tow package that Ford sold for that car. He just figured, well, I know how to wire stuff up. I'll just use one of these little Scotch locks, you know, where you pinch the little thing and it bites into both wires. And that was a bunch of stuff melded together. That's what made me think of that.
Yeah, lights and everything probably start working dead.
Well, when you switched it off, the park lights would stay on and the engine would keep running. I mean, that's how many wires were hooked together, the whole doggone wire harness. It would have cost him more for us to split that wire harness and fix it, because of the fact that we were getting as much per hour as we get at the dealership, you know. Dealership charges nearly $100 an hour, you know, for the work that you do and all that. But anyway, let's see here. If 12 volts are being applied to a resistance of 3 ohms, how many amps will flow?
4.
You guys are swoofed. Very cool. You remember Ohm's law, don't you? High resistance in an electrical circuit can cause what?
I'd say all of
Clicking
it.
of relays.
Any of the above.
Yeah, dim lights. All right, let me ask you this. What am I gonna do if I've got dim lights, a slow motor operation? What am I gonna do to, where am I gonna start on that?
Fuse box.
Voltage drop test.
Good answer, Lundy.
Well,
Yeah, dim lights, slow motor operation, and all you gotta do, and it's real easy to do, you go to the hot battery terminal, and you go to the place where thing's being fed power, and you have somebody operate the circuit, and you see how much you read. If you read a high voltage reading there, you're losing that much between the switch and the motor. Then you're gonna go toward each other, like you're gonna find, I'm gonna go where power goes into the switch, and I'm gonna go where power comes out of the switch. If it's dropping the voltage there, your switch is bad. Got me? That ain't complicated. Everybody needs to understand that. Okay, if 2 amps flow from the positive terminal of a battery and operate a starter motor, how many amps will flow back to the negative terminal of the battery?
200 amps.
200 amps. It's the same all the way through the circuit. 13, inductive ammeters work because of what principle?
magic.
A magnetic field surrounds any wire carrying current.
That's those amps.
Yeah, Tubby.
Clamp on it,
Set it
right?
down on top
Clamp
of
the wire.
hood for you.
Okay. All right, let's see. Oh, what do you
If
do?
I got a thermostat for me on Friday or Thursday, can I still replace it if it needs to be replaced?
No, we don't replace faulty parts with advanced auto parts. You can forget that.
No, do I have to pay for it?
That's what I was saying. Yes, you have to buy another one.
Don't play with me right now. I need to.
We got
buy
one out of the
something else.
back box that was frozen or something?
Well, she's actually said it was okay for a little while and then
For like
it
a
went
day.
south.
You still have the box for it?
Hello?
Fixed pool hall.
Just pull it out.
Oh,
pull it
no,
out, bring
come
the
on over.
receipt with you, and then we'll just do a
Well,
defective
I'll
exchange.
send it through before we do pull it out.
Okay.
Yeah, she'll get it out. And then she can use the box that the new one comes in. If it needs another thermostat, which I'm not sure it does. Okay, so
What's it doing?
getting hot.
And get it hot.
Backing up and getting hot?
Yeah. Why did you change it? Because you didn't know heat?
No heat.
No heat. Now,
And it
now,
through it- and it through a thermostat.
I'm just telling her to make sure it's full of coolant first. You start with what's cheap and easy, right?
Right.
Of course, the thermostat's fairly cheap and fairly easy too.
You want me to set this on your desk?
Yes, sir, if you don't mind, thank you.
I just wanted to make sure.
A meter used to measure amps is called a what?
Amp meter.
And we-
Which answer is that?
C.
No, it's actually C, believe it or not.
See,
I said C.
Ammeter. Ammeter. I would have say amp meter, you know, it makes you want to say amp meter, but it's ammeter. You know what a coulomb is?
Actually, I don't.
1 billion electrons.
1 billion billion. How
Yeah.
what?
A coulomb is 1 billion electrons. An ohmmeter should be connected to the circuit or component being tested how?
D,
Huh?
No.
no,
Only when no power is flowing.
Yeah.
That's right.
Did you know you can have this ground loop thing going on? If you take a meter, like if I got a meter like one of these right here, and I go, if I've got a battery hooked up on the car, and I go from the engine block to the body, and I'm measuring on both ends of a ground lead that's hooked, you know, even a short ground lead, it's gonna measure all kinds of crazy voltage and all there, because the battery is not unhooked. Anytime you're measuring ohms, that's a part of the wire harness or engine to body or anything like that, always disconnect the battery or you will get screwed up readings. Now, if you're just measuring, like you and I were measuring at variable orifice steering
No
system,
power to it.
there was no power, well, there was no ohms, there was no power to it, it was just a, you know, standalone atom. And that the reason that steering is so easy all the time, Melissa, is that little actuator is burned out.
Really?
No, it's supposed to have 20 ohms and it's got nothing. So
That-
that's enough, yeah. Wasn't too complicated to figure that out. You know what my rule of thumb about parts that fail is? The part that's in the most hostile environment that's doing the toughest job is the one that usually fails. And on that car, what's in the most hostile environment that's doing the toughest job? That little actuator. It's busting its fanny. It's in a hot place. It's working hard. It's got 1,500 pounds of fluid pressure going through it all the time.
Mm-hmm.
We talking really is crucible here, man. All right, so, all right, let's see. A meter is set to read DC volts on the 4-volt scale. The meter leads are connected to a 12-volt battery. The display will read what?
B.
Oh, well.
OL means, some people call that overload, out of limits, whatever, you know, OL is what it is.
I thought that just meant that it was a.
KHZ is a unit describing what property?
Kilohertz frequency.
Well, what is a hertz? What is 1 hertz?
It's a cycle,
1 hertz is there a time factor here somewhere?
1 cycle per second.
Per second, listen to that guy, 1 cycle per second. And I used to have these cars that had this air suspension on the old Lincoln vehicle I worked on back in the early 80s. And they would say whenever you open the door and close it after you enter self-test, the light would flash at 1.8 hertz. I was like, well, you supposed to measure this or what, you know?
No doubt.
Yeah, so, which means it's a little more than once a second. All right, let me see here, we're almost done here. To prevent blowing the meter or fuse in a DMM, what?
D.
Huh?
A,
Both A and B. Put a fuse in line with the meter lead, never test resistance of the energized circuit. These big old fluke meters, the fuse in these fluke meters costs about $7. And that's why I'm not using fluke meters whenever you've got people learning, because these little glass fuses that go in these $10 meters don't cost that much. All right, so let me see here. What type of DMM can measure a circuit when clamped around a conductor?
that would be an inductive
That
amp
is a
meter.
C, inductive ammeter. Number 20, when measuring resistance, a reading of OL on the DMM indicates
None of these.
resistance now.
Oh,
Open.
open circuit.
Yeah. What did we read on that actuator a while ago? Lenny?
Oh, well.
We did.
Well, no, we read number 1. It said 1.
Yeah, on that one it doesn't say OL. They're always thinking about a fluke meter. You know, these meters don't say OL on them. They didn't want to put the circuitry in there to spell out OL because the word was too long or something.
You really